Hello and welcome back to Get Great at Maths. I'm here to help you pass your maths exam, so hit that like and subscribe button. We're going to look at keywords, key formulas and how to gain top marks. So let's get ready to get great at maths. We're going to look at differentiation and points of inflection. Now we're going to be looking at all the key facts linking to points of inflection. Now a point of inflection is a graph where the gradient on either side of the stationary point in the middle is the same. So in this case, the gradient to the left hand side of dy by dx equaling 0 is positive. The gradient on the right hand side of dy by dx equaling 0 is positive. So the gradient is the same on either side of the stationary point, and the stationary point here is at the point A. Now dy by dx equals 0 here, but that is not the only type of stationary point you can get. You can also get when dy by dx doesn't equal 0, and in this case the gradient either side of dy by dx not equaling 0 is a negative gradient. So the gradient is the same either side of that turning point, but the dy by dx does not equal 0. So in this case we have to use d2y by dx squared equal to 0. Once you've found that, you then need to find the value of x. Once you've got that value of x, to prove that this is a point of inflection, you need to show there is a change in sign in d2y by dx squared. So either side of that d2y by dx squared, you need to put an x value in above and below to show that you have got a change of sign, and then this will prove that you have got a point of inflection. Now we're going to look at an example, and we're going to be using the key facts that we've just looked at, where d2y by dx squared equals 0. We're then going to find x. We're then going to look at the change in sign in d2y by dx squared either side of that x value to prove that you have got a point of inflection. So the key words in this question are prove, point of inflection, x equals 1, and y equals x e to the minus 2x. So we're going to have a go at solving this question. Now to start with, we're going to use the product rule to differentiate this function, because we have got a stationary point which is a point of inflection. And to differentiate this function, we're going to use the product rule because I've got two things multiplied together. So my first thing is x, which is in blue. So I do x, which is my first term, times the differential of v, which is the second term, which is in yellow, e to the minus 2x. Now the differential of e to the minus 2x is minus 2 e to the minus 2x. Then I'm going to add on the second, which is e to the minus 2x, times by the differential of the first, which was x. So the differential of x is 1, so I'm going to multiply by that 1, which gives me product rule for differentiating this function. I'm just going to tidy it up, and I'm going to write it as minus 2x e to the minus 2x plus e to the minus 2x. Now when we're looking at finding a point of inflection, the key fact says that d2y by dx squared equals 0, so we need to differentiate again. Now I've got two terms, but the first term is still two things multiplied together, so we need to use the product rule on the first term again, and then the second term just differentiates on its own. So differentiating the first term using the product rule again, I've got the first term, which is minus 2x, which is in purple, times by the differential of the e to the minus 2x, which is minus 2 e to the minus 2x, plus the second, which is e to the minus 2x, times the differential of minus 2x, which is just minus 2. I then have to multiply by the differential of e to the minus 2x, which is minus 2 e to the minus 2x. I can tidy this up to give me 4x e to the minus 2x, minus 2 e to the minus 2x, minus 2 e to the minus 2x. Simplifying further gives me 4x e to the minus 2x, minus 4 e to the minus 2x. From here I can factorise the common terms, which are 4 and e to the minus 2x. So I take that outside the front of a bracket, leaving me with x minus 1 in the bracket. From here I get a point of inflection when d2y by dx squared equals 0. Make sure you state the key fact. Putting 0 equal to my function, I get 0 equals 4 e to the minus 2x bracket x minus 1. Taking each part equal to 0, I get 4 e to the minus 2x equals 0, or x minus 1 equals 0. Now the exponential curve is always positive, which means that there is no solution on the left hand side, the bit in light blue. but on the right hand side I get x equals 1. So we have shown there is a stationary point at x equals 1, which is a point of inflection, but we have got to prove it. Now to prove it, we're going to choose a value either side of x, either side of 1. So I'm going to choose a smaller value and a larger value, and I'm just going to choose x is equal to 0.5. Now if I substitute x is equal to 0.5 into d2y by dx squared, I get 4e to the minus 2 times by 0.5 bracket 0.5 minus 1. Now 0.5 minus 1 is a negative number, 4 is obviously positive, and the exponential function is always positive. So two positive terms multiplied by a negative term is going to be a negative term, which is less than 0. We don't actually need to work that value out, we can just work out in our head that this is going to be negative, and that is enough. Picking a bigger value bigger than 1, x is equal to 1.5, if I substitute that in, I get 4e to the minus 2 times 1.5. Now 1.5 minus 1. Now 1.5 minus 1 is going to be positive. Times that by positive number again, this is going to be positive, so this is greater than 0. So I have shown there is a change of sign, therefore we have got a point of inflection, and we have proved that there is a point of inflection when x equals 1 on the curve y equals x e to the minus 2x.
If you've enjoyed this video, please don't forget to like and subscribe. Comment below to let me know what you would like to see in my next video. See you next time!